Hi and welcome to this third video of the TypeScript course. Today I want to discuss type unions and type intersections. Type unions and type intersections are quite easy, I think, in a conceptual term. They are quite straightforward to understand. But we need to think about them in two different ways. We need to think about the universe of objects and we need to think about the universe of properties. So that's what I want to clarify in this video. And I want to show you the differences between the two and what happens when we are doing a type union in TypeScript and what happens when we are doing a type intersection. You will use them quite often, type unions and intersections, so it's very good for us to dedicate a little bit of time to understanding how they work in TypeScript, because sometimes when you start working with them, you actually can get a little bit, things can get a little bit confusing. So we'll start by talking about the type unions and then we move on to talking about type intersections. Before we jump into the code, I want to draw a little bit with you, do a little bit of diagrams, a few diagrams and a few exercises to understand how TypeScript actually handles the type unions. So here I'm just going to write, let's say, type unions, right? So type unions. And the idea here is that, well, so let's say that I have some variable, so some const, my var, right? My var, and this variable, it can be either let's say a string, or it can be an array, right? So it could be, let's say, an array of number, right? So number and then an array of numbers, right? This is going to be my variable. Actually, maybe here I could say even let, just to make things a little bit easier, because then I don't need to initialize it. But anyway, let's leave it to const, right? So the idea here is that, well, for TypeScript, let me see here, change a little bit the color. So we have two universes. We have the universe of strings, which is this universe here. I'm going to call this universe the universe of strings. And we have the universe of, let's say, arrays, right? So we have the universe of arrays here, right? This is the universe of arrays. And for TypeScript, actually, more specifically here, we would actually have the arrays of numbers, right? Because arrays of numbers are maybe a subset, not maybe, but for sure a subset of arrays of every other possible type. So we have the universe of arrays of numbers and we have the universe of strings. So from TypeScript's perspective, actually here, any type or any value that satisfies either the string constraint or the array of numbers constraint is good enough. So basically, TypeScript will accept values which are in all this universe here, in all the domain, right? So every element of this union here, this union of these two universes, is allowed. Now, as you can imagine, this is one side of the coin, right? This is explaining which values I can provide to the myvar variable. Now, my question to you is, based on this, so based on these values that I can provide to the myvar variable, which assumptions can TypeScript make about the shape of this myvar variable? So whatever value is in there, which safe assumptions can TypeScript make? By that I mean, how can TypeScript actually work with this value here, or with the properties of the myvar const, or of the myvar variable? And as it turns out, because it can be either a string or an array of numbers, then TypeScript can really safely assume that only the properties which are common to both will be available all the time from within the, or for the myvar variable. So here Now, this is perhaps the place where people get most confused. Then the safe, let's call it like this. I'm gonna write this in blue a little bit, in a little bit. Let me just mark this here and then draw this here like so. And then here I'm gonna say this is the safe properties, right? So let's call it quote unquote safe properties, because independently of whether the value is a string or a number or an array of numbers, it will contain the properties which are in the intersection between the two types. If the type is a string, it will not contain some of the methods that an array of numbers contain. And if the value is an array of numbers, it may contain some other methods which are not available for strings. So in this parts here, so let me just make a little drawing. So in this parts, or in this elements, not elements but regions, in these regions, TypeScript really depends on, it needs more information about the variable to actually determine which one it would choose. For us here, in the context of the type unions, it's important to understand that safely TypeScript can only assume the properties which are in the intersection between the two types. These are the safe properties. So now let's see how this looks like from the code perspective. I'm gonna delete, this was the stopping of the previous video, or the stopping point of the previous video. And let's see how we can work with unions in TypeScript. So here, for the sake of demonstrations, let's see, we'll just have print length. And this print length is going to be a function, and then it's going to return some or is going to receive a certain value, and this value can either be a string or an array of numbers, right? And this is going to return void. So here that's an arrow function, and then we'll simply say console.log file dot, and as you can see here, the properties that show up, they are not all the only properties, I mean properties and methods, right? But they are not all the methods and properties of strings, nor all the methods and properties of arrays. They are really only those which are here in this intersection, right? They are only those which belong to the two of them. If I were to write, for example, if I were to try to access the find method, this is not allowed because find is really an array method rather than both a string and an array method. If I were to remove this, then the method becomes allowed, but here I'm actually just missing the callback. I could say like element is equal to 10, right? So something like this. I'm just trying to find the element 10. So here, as you can see, due to the type restrictions, TypeScript is only able to allow, or it will only allow us to work with the methods that are available to both string and number, right? As you can see, this is also very, very helpful. So here length is, for example, one of them, and then we can safely print the length of both strings and arrays of numbers. This is really the basics of type unions, and I think that for a long time we can work with this simpler definitions, or just with this overview of type unions. And if there are some details later on, we'll talk about them when the time comes. But let's move on to talking about type intersections. So let me just write here type intersection, type intersections. And the idea here is that, well, it's going to be pretty similar to what we talked about. I mean, no, it's not going to be similar. I mean, the concept is the same. We are combining two different types and performing some intersection operation with them. But let's understand how this works for TypeScript. So I will actually define two additional helper types here for us, just so that we can work with this intersection in a more realistic scenario. So I'm just going to say interface. I'm just interface. I will say person, right? So that's our first interface, and it has a first name, f name, which is a string, and it has a last name, l name, which is also a string, right? This is the first helper interface that I want to declare. And the second helper interface that I want to declare is this one, interface, let's say printable. And maybe you have some reservations against using this type of interfaces. It doesn't really matter. The idea here is that I will just say print full name, right? So here the idea is that print full name is just going to be a method which is going to return void, okay? And these are the two interfaces that I actually want to use. And let's say that I have a function, or not a function, but a value or a person here. And this person is of type person and printable. Person and printable. All right, so this, and then here that would be the actual instantiation of the person. So what this is saying to TypeScript, right? So to TypeScript here, let's again draw our two little circles just to understand. We have the universe of persons, right? We have the universe of all the objects which comply to the shape of the interface person. And then we also have the universe of the printable, right? So here we have, or maybe I should make this a little bit bigger, the intersection at least. We have all the universe of, or the universe of all the objects that comply with the interface printable. That means that have a method which is called print full name, which is a method that receives no parameters and returns nothing, right? So we have these two universes. And when I say that a certain variable person has to comply to both of them, then what it means is that it will lie in this little region here. So it is going to be both, oh, that's horrible. It is going to be both of type person and type printable, right? So now it is going to be only the set of objects that lie within this intersection between the two type universes. Now, this is from the type perspective. This means that only the objects which contain an F name, an L name, and the print full name properties will be accepted as valid persons, right? So of course, here maybe the name is not very good. I have a person and then a person here as well, but this doesn't really matter. I mean, I'm not too worried about the names here. I just want to really give examples. Now, okay, so from the properties that TypeScript can access, so from the perspective of the available properties, I ask the same question: which properties can TypeScript safely assume that will be available in our person variable, in this variable here? So the properties are basically pretty much every property from either from both the person and the printable interfaces. So from a properties perspective, everything here is really available safely to TypeScript, because we are telling beforehand that whatever value is assigned to this person variable here, it will comply to both this interface and this interface. That means that all the properties and all the methods of this interface will be available, and all the properties and all the methods of this interface will also be available, right? So this is pretty cool. So let's see how this looks like in the code. So I'm going to delete this whole thing here, and I'm going to create the interface person, as I said. And this person here is going to have an F name, which is going to be a string, and an L name, which is also going to be a string. And then I'm going to declare another interface, which is going to be the printable interface. And the printable interface is going to have a print full name method, which is going to be of the same signature that we set in the diagram. So now let's try to create a person. So my person, right? Let my person is going to be of type person and printable, like so. And here, let's try to already instantiate this. And if I actually instantiate this, then you will see that we have an error. Now, if I hover over this error, you will see that the type is not assignable to person and printable. The type is missing the following properties from type person. Okay, so let's provide the type person. F name is John. L name is Doe, like so. And oops, we still have the error, right? If I hover over here, then you will see that the type is not assignable to type person and printable. The property print full name is missing in this type, but required in the type printable. So TypeScript is saying, okay, you're telling me that this person here, this variable my person, is going to comply to both of these interfaces. Very well. Okay, it complies to the first one. That's okay. But the second one is not really the case. It's missing something here. So once we actually provide the method, the print full name here, and we don't need to do anything, could be like an empty method because I don't need to return anything. But for our purposes, let's just console.log the first name, this.fname, and then this.lname, like so, right? So as you can see, it's pretty easy now for us to actually create an object containing all the properties of the required, let's say, interfaces or base interfaces, base types that we are actually informing here to TypeScript when typing this variable. Now, if I were to actually switch this to a function, right? So I'm going to just make this a function like so, and I'm going to say const do something. And this is going to be a function like so. And I know that is not really nice. So I'm just going to remove that. And here I can say my person. And the moment I say dot, you will see that it really prints out, or it shows me in the autocomplete the properties from all the interfaces which are mentioned here. Remember that in the union types, we were showing the properties that were common to all the interfaces, that were the intersection between all the interfaces or all the types that we were informing. In this case, the properties that are shown are the union of all the properties. Now, maybe that's where I mean that things get a little bit confusing, is because for type unions, we actually show the intersection of properties, but for type intersections, we show the union of properties, right? So this may take a little bit of time to understand, but hopefully the diagrams and the discussion is helpful in this direction. So here, TypeScript can safely say, okay, the myPerson parameter is actually going to comply to both the person interface and the printable interface. So I can access any property or method from the person interface and any property or method from the printable interface. So to wrap up, I just thought, well, it makes sense to write a little summary, right? So here, let's say summary. And for us to really understand the differences and all the things that I mentioned during this video, because actually I talk with my hands a lot, but I just figured out that you're not seeing my hands when I'm talking, so maybe it's harder to understand. Here then there are two, so we have here the union, right? So type union, I'm gonna say type union. And we have the type intersection, like so. And here, let's say that we have like two like placeholder types A and B, right? So we have types, these are our types A and B. And then here, so let me just create some lines here for us to separate everything. And here I want to draw the 4 diagrams actually that I drew throughout this video. So the first one is the, let's say, value universe, right? So the value universe which TypeScript accepts when we are creating union types, that's simply A or B. And here for the intersection is A and B, right? And here I actually want to also draw a diagram for the safe properties. These are the properties that TypeScript can for sure say that belong to this union or this intersection type. So here the value universe, well, we have again, it's going to be pretty much the same for all of them. So that's type A and this is type B. This is again type A and type B, right? So type A and type B. This is also type A and type B here, type A and type B, and this is also type A and type B. Now the difference here is that this diagram, so I'm just gonna let me highlight with a different color. So these diagrams, this one and this one, they don't refer to the universe of values that satisfy the type A and type B. They refer to the properties of types A and properties of types B, right? And so the idea here is that in the union, we will accept every object from either type A or type B. And so this is the value universe for us. Any object that satisfies either the A constraint or the B constraint will be accepted by TypeScript. If this is the case, then as it turns out, for the safe properties, TypeScript can only for sure say that it can access the properties that belong to both types, right? So these are the only safe properties that TypeScript can actually access if we are working with a union. Now, as it turns out, if we are working with the intersection, then the value universe will be only those types that satisfy both the A and B constraint. On the other hand, the safe properties will actually be all the properties from both A and both B, because we are ensuring that all the values or any value that is assigned to this variable or whatever that has this type intersection, they actually satisfy both the A and B constraints. Therefore, TypeScript can safely access any property from both A and B properties. So these are the four different diagrams that we discussed today, and I just wanted to make this quick summary to make it very clear what I mean when I talk about the value universe and when I talk about the safe properties. And hopefully by now it's quite clear how both union types and intersection types work in TypeScript. That's it for today, and I hope that the difference, the characteristics of both type unions and type intersections are now clear. And actually, with what we discussed in the previous video and in this video, we can go a long way in TypeScript. There are, of course, other concepts that we will still cover in this introduction course, for example, classes and generics. But really, if you try to use the stuff from the previous video and the stuff from this video, I think you can actually go a long way. So keep that in mind. As you can see, the TypeScript introduction is not going to be as long as the JavaScript one. And that's really because I think that TypeScript is better understood in practice, right? So when we are actually working in applications and when we are actually exploring the documentation that is out there, and when we are writing our own types for an actual use case. So with that being said, in the next video, we'll discuss the difference between type aliases and interfaces. I mean, you can pretty much use both interchangeably. It's going to be a short video. I just want to show you the syntax, right? So far we've worked only with interfaces, and I want to show you what type aliases look like and what's their difference to interfaces, and then make a couple of arguments. I personally prefer type aliases, and maybe you will get some different opinions online. People will say different stuff, and it's really up to you to decide which one suits you best. I just want to present the two possibilities. So if you don't want to miss that, and I think I'm getting repetitive at the end of my videos, but anyway, at least I leave the subscription call to the end of the video, right? Anyway, if you don't want to miss that, subscribe to the channel and you'll get a notification when the video is out. Thank you, and I'll see you in the next video. Bye bye.